All right, everyone. Sorry for the delay. All right. So the green assignment, guys. So Graham, Kendall, you guys can tuck that away. Where you guys are doing a new lesson today. You guys can feel free to work on that afterwards. Because I think some things we do today are also kind of things you're doing on the assignment, so it should help. But yeah, this is one of the days, the first day of this unit, where you guys have to get done the 3U stuff. The 3Ms will just have another day to practice what they learned for the first 3 days. So we are learning about what we call the reciprocal trig ratios. So I often get asked when we do this, it's like, why are we learning about these things? And to answer that, it's kind of hard to explain to you guys how these things can be useful until you get to maybe taking some engineering courses in university, which not everybody is going to do. But what we're doing today is very useful in applications like engineering, and these things pop up in calculus. So this is where they're introduced in the Ontario Math curriculum, these reciprocal trig ratios. So what are they? Well, we'll get to that in a second, but I want you guys, as a bit of just a warm-up, can you guys draw your 45, 45, 90 special triangle, your 30, 60, 90 special triangle, and then combined with our unit circle, we're going to get the exact values for the sine, cos, and tan of all these angles, these special angles. And then this second half of the table will just be a little surprise for later. But yeah, right now, let's do our, I'll get you guys to do your special triangles. Use the unit circle. I'm going to resist the urge to just do it for you. But let's see how much of this you guys can get done on your own. I think at the very least I can maybe draw the special triangles with you guys. And I have the luxury of, can I make triangles? Yes. Hold down shift for a right triangle. Oh, look at that. Today I learned. No, I don't like it that way. Oh, it even tells me the angles too, so I can make the scale drawings. Fantastic. Let's do that. So your 45, 45, 90, draw an isosceles triangle with side lengths of 1, and then Pythagorean theorem says the hypotenuse is root 2. And then your 30, 60, 90 triangle, an equilateral triangle cut in half. That triangle had side lengths of 2. Cut the bottom in half is 1. And Pythagorean theorem is root 3. So maybe I can do 2 of these with you guys, and then have you guys maybe try the rest as a bit of a warm-up exercise. For example, let's do 90 degrees. So as you guys have been learning with Miss Goby, points on the unit circle, and there's space for this, so why don't you guys jot this down? Points on the unit circle correspond to a specific angle in a standard position. So for an angle theta in standard position, every angle theta has a corresponding point on the unit circle, and that point corresponds to the cosine and the sine. So let's do 0 and 90 degrees together. The point on the unit circle corresponding to 0 degrees is 1, 0, which means the cosine of 0 is 1, the sine of 0 is 0, and the tan of 0 is just sine over cosine. 0 over 1 equals 0. And then what point, one of you guys can tell me, what point corresponds to the angle 90 degrees on the unit circle? Enhance, enhance, enhance. What point corresponds to 90 degrees on the unit circle? Jillian? 0, 1. That means the cosine of 90 is 0. The sine of 90 is 1. And the tan of 90 is 1 divided by 0, which we said was undefined. So having done those two, I think you guys can try 180 and 270. I'll do the sine, cos, and tan of 45 degrees with you as well, and then let you guys try to finish it off. For 45 degrees, maybe focus in on the bottom right one. The adjacent is 1. The hypotenuse is root 2. The cosine of 45 is 1 over root 2. And so is the sine, because the opposite is 1. So 1 over root 2, 1 over root 2. And of course, tan, using a special triangle, is opposite over adjacent. And 1 over 1 is just equal to 1. All right. I did a lot with you guys. I think a good little exercise would be for you guys to do the remaining of 1, 2, 3, 4 rows. And then we'll pick up the new lesson from there. Maybe we'll do my attendance while you guys try that. And I'll be sure to pause the recording. Of course, you guys won't let me forget to unpause. Can somebody different tell me the point that corresponds to 180 degrees? Graham? -1, 0, which means the cosine of 180 is -1. The sine is 0. And the tangent of 180 is 0 divided by -1, which is equal to 0. And then one last person, what point corresponds to 270 degrees? Who's that, Mackenzie? 0 and -1? No, sorry. I think I messed that one up. It is, right? Oh, it is because I have cosine sine backwards. Thank you. So 0, -1, right? Thank you very much. And then the tangent of 270 would be -1 divided by 0, which is undefined. And if you guys want to humor me, you can try that yourself. Try sine 270. Your calculator will spit out -1. Try cosine 270. Your calculator will spit out 0. Try the tan of 270. Your calculator will spit out an error message because it's undefined. All right. And then for 30 degrees, opposite is 1. So the sine of 30 was 1/2. The adjacent was root 3 over 2. And the tan of 30, opposite over adjacent, 1 over root 3. And for 60, things just flip-flop. Root 3 over 2, 1 over 2, and root 3. Of course, those 3, along with 0 and 90, you guys have done those several times. You guys did it on your trig unit test. But I wanted to do these other 4 as well to just reinforce some things you guys did with Miss Goby on the unit circle. So a good tying in of everything together. Now, later on today, we're going to use the cast rule to determine the exact values, not just for these guys, but for any angle that has a reference angle of 30 or 45 or 60. So we're going to be able to do the exact values for 150, 210, 330, -30, all kinds of angles. In fact, I think 210, I believe, is on the next page. So I'll just make an arrow. We will do this together. We will do this. And if you're wondering what the second half of the table is for, you're going to have to hold on for just a moment. This is a spot where I'm going to introduce the 3 reciprocal trigonometric ratios. Now, reciprocals is a term you guys have heard before in earlier grades. You might not have used these in a while. Does anyone know what reciprocals are? I'll tell you formally what they are, and then kind of informally, and then give you guys a couple of examples of reciprocals. So I'm going to type this in. Reciprocals are, let me just maybe get a bigger font size. Expressions, make this bigger. 2 expressions, I should say. That multiply to 1. That's what reciprocals are. So what are some examples of reciprocals? So things like, let's get a nice color. green. So for some examples, the reciprocal of 2 is 1 over 2, because 2 and 1 over 2 multiply to 1. Another example of some reciprocals, numbers like 3 over 4 and 4 over 3. Because when you multiply 3 over 4 and 4 over 3, you get 12 over 12, and that's just 1. But you see with both of these, they're just the flips of each other, right? Yeah. So informally, you guys can think of reciprocals as just being like a flip. And that's like the easy way to think about it. So just in brackets here, I might say, i.e. flips of each other. So that's not a formal math word, but I think it'll help you guys remember. Flips of each other. And that brings us to our 3 reciprocal ratios. Every trig ratio you've learned so far, you guys have only learned actually half of the trig ratios. You guys thought sine, cos, and tan was it. There's actually 3 more. The reciprocal of sine, the reciprocal of cosine, and the reciprocal of tangent. And you guys will never guess what the reciprocal of the sine ratio is called. It is called the cosecant ratio. Cosecant ratio. And just like sine is 4 letters, but we shortened it up to 3 letters, S-I-N, we shortened cosecant up in the following way. We use the 3 letters C-S-C. The cosecant of an angle theta is the reciprocal of the sine of theta. It's just the flip of sine theta. It's 1 divided by sine theta. And in the same way, cosine has one and tangent has one. The reciprocal of the cosine ratio is called the secant ratio. And its short form is SEC. The secant of an angle theta is 1 divided by the cosine of angle theta. It's the flip of cosine. And lastly, the reciprocal of the tangent ratio we call the cotangent ratio. And the short form we use for that is COT. It is 1 divided by the tan ratio. 1 over tan theta. It's the flip of tan theta. You know what? Sorry to disappoint all my viewers and subscribers out there, but I don't think we need double Mr. Smith today. We'll just take out the camera. All right, those are the 3. And today what we're going to do the same things you've been doing with Miss Goby pretty much. We're just going to do them with these ratios here. So as I said, a lot of the stuff on that green assignment we're going to do today, it should help you guys out. Now, I think I'd like to actually do these examples a bit out of order. Let's do this first one together. The cosecant of 216 degrees. Now, if you guys eyeball your calculators, do you guys have a cosecant button? A CSC button? No. Some of you guys, I don't know, maybe somewhere deep in your all the different second functions you guys have, it's possible you could find it somewhere, but most calculators don't have a cosecant button. So what we do is we just use the definition. The cosecant of 216 degrees is just the flip of the sine of 216 degrees. It's just 1 divided by the sine of 216, which you guys can just punch into your calculator. 1 divided by the sine of 216. And I'll go to 3 decimal places. That's kind of been the standard so far, this unit. About negative 1.701. Did you guys get that too? It's just calculator work, but we're using this new definition. It's just the flip. So secant of 25, there's no secant button on your calculator. It's just the flip, the reciprocal of cosine 25. 1 divided by cosine 25. Whatever that is. about 1.103. Can you guys try the last one using the same idea? Cotangent is the flip of tan. I'll wait a second. You guys try. I'll just wait like 20 seconds or so. All right, I'll come along for the ride now. So this would be the flip of the tan of 160 degrees, whatever that is, 1 divided by the tan of 160. Did you guys get negative 2.747? About? Okay, very good. So these are the reciprocal ratios. You don't have a button in your calculator, but you can just evaluate these by just using their definition. They're just the flips of the basic three. Anything you guys want to clarify so far? So far, just been some definitions. And don't worry, we don't have to relearn all the trigonometry from last unit with these guys. Sine, cosine, tan was enough for triangles. All right, let's do some more exercises. I think let's actually do the bottom example first, and then we'll head back to the front and do all the reciprocal ratios for the ones in the front. So this is a good exercise for things to review some things Miss Goby did with you guys. On the left here, can you guys just make a sketch of 210 degrees, in which this should almost be kind of a reflex at this point? Can you also label like what the reference angle is? What is that related acute angle that terminal arm makes with the x-axis? So 0, 90, 180, 270. So it's somewhere in here. Somebody who hasn't helped out yet today, what's that reference angle for 210 degrees? Maybe somebody who hasn't helped out today? It's a little bit of a layup. Okay, Mackenzie, go ahead. 70? Not 70. So 210 degrees, how much past 180 gram? 30 degrees. All right, so as you guys have been learning, the sine, the cos, the tan of 210 degrees will be the same numbers as the sine, cos, and tan of 30 degrees, except the signs will be different according to the cast rule. Can you guys do me a favor? Before we do anything else, can you guys just put plus, minus, minus, or minus, plus, plus, just the sign of all these, and hence the sign of all these too. Just take a second and do sine, cos, and tan. What are the signs? Put a plus, put a minus, whatever the sign should be. If you need to write out your cast rule on your diagram, that's not a bad thing. For some of you guys, you just do that every time anyway. Not a bad idea at all. In fact, I will do it too. I have the luxury of using a different color. Somebody give me the rundown, maybe somebody who hasn't helped out yet today. What are the signs from sine, cos, and tan as we go down? Mackenzie, redemption for this one. Negative, negative, positive. We're in the tan quadrant. So I'm just going to write that down. Negative, negative, and positive. We know their signs. But what will the numerical values be? Well, they'll be the same as 30 degrees. What's the sine of 30, the cos of 30, the tan of 30? Well, don't we just have those on the front side, everybody? They're right here staring us in the face. There's the sine of 30, it's a half. There's the cosine of 30, it's root 3 over 2. And there's the tan of 30, it's 1 over root 3. 210 has the exact same numbers. We just got to copy them over. So the sine of 210, I've already forgot. The sine was it 1 over 2 or root 3 over 2? Sine is 1 over 2. So negative 1 over 2. The cosine, minus root 3 over 2. And the tan, 1 over root 3. These are the exact values for 210 degrees. How did we get there? Cast rule for the sines. And then the related angle is 30 degrees. We just copied them over. They'll have the same numbers. All right, So that's kind of an expectation for you guys now. Last unit, we were working with triangles, mostly triangles that had acute angles. 30, 45, 60, we should have had down or at least have been able to draw the special triangles. Now, the expectation for 3U students is to be able to state the exact trig ratios for any angle like 210 that has a reference angle that's 30 or 45 or 60. But just comes down to the cast rule. We're going to go one step further. Now let's get the cosecant and secant and cotangent of 210. And all it is just doing the flip. What do you guys think the flip of negative 1/2 is? If you take negative 1/2 and you flip it, Jillian?
Negative 2/1?
Yeah, it's negative 2/1. Are you guys okay if we just do negative 2? Note the sign doesn't change. When you take a reciprocal, the sign is unchanged. We're not like in grade 9. Do you guys remember grade 9 doing perpendicular lines and it was perpendicular slopes were negative reciprocals? I taught some of you guys that. No, we're not taking the negative. We're not changing the sign. We're just, sign is unchanged. We just flip. And so the secant of 210, it's going to be negative. And then we take root 3 over 2 and we flip it. 2 over root 3. For the cotangent of 210, it's positive, and we just flip 1 over root 3. When you flip 1 over root 3, you get root 3 over 1, or just positive root 3. So at this point, this will be a good exercise too. And then the remaining questions we're doing, I think we just have a few more examples on this next page, or we'll kind of help you guys out with your assignment. Can you guys flip to the front? And let's talk about the cosecant of all these ratios. This secant, or of all these angles, and the cotangent of all of these angles. We don't have to do any other work except take the reciprocal. This is an interesting question. You guys ever, maybe it hasn't occurred to you this class yet, like, what's the reciprocal of 0? That's kind of weird, right? When thinking about the cosecant of 0. But if you think about cosecant, it's just 1 divided by sine. What's 1 divided by 0? You guys can do it in your calculator if you're still unsure. What does your calculator give you when you do 1 divided by 0? An error, right? So the cosecant of sine is undefined. Why? I might even just do, because if you do 1 divided by 0, that's undefined. The secant of 0 degrees. What's the reciprocal of 1? Anybody think they have that? What's the reciprocal of 1? Graham? It's 1, right? It's just 1 divided by 1, which is just 1. And we already talked about the reciprocal of 0. When you do 1 divided by 0 is also undefined. 1 over 0 is undefined. I'm going to do the next one with you guys and then see if you can do 180 and 270 by yourselves using similar patterns. All right, what is the cosecant of 90 degrees? Well, it's just the reciprocal of 1, which is just 1. The reciprocal of 0, 1 divided by 0, is undefined. Now this one's kind of wild. How about the cotangent of 90 degrees? The cotangent of 90 degrees. The tan of 90 was undefined. So what's the reciprocal of that? Anybody have a guess? What's that? No? What do you think, Jillian?
I think the answer would be 0.
It is 0. Yeah, just like with these guys, 0 and undefined, and 0 and undefined works the other way too. If you take 1 over 0, which is undefined, but you flip it, you get 0 over 1, which is just 0. Very cool. All right, can you guys try 180 and 270? It's either going to be 0, undefined, or -1. I'll wait like a minute or so, let you guys give that a try. all we're doing is we're just flipping numbers around. We're flipping 0, we're flipping -1, and we're flipping, well, I guess 0 again in that. 180 looks a lot like 90. We're going to get undefined, the flip of 0. Don't know what letter I was just trying to write there. Undefined. Undefined. The flip of -1. Remember, we're not changing the sign. 1 divided by -1 is just -1. And the reciprocal of 0 is undefined. You can just automatically pop that in there. And then for 270, you flip -1, you get -1. You flip 0, you get something that's undefined, 1 over 0. And when you take -1 over 0, which was undefined, but if you flip it, you get 0. It's kind of similar to 90 degrees, except with the negative sign. All right, so we've learned about the 3 ratios. They're just flips of sine, cos, and tan, and we've just done a bunch of exercises in flipping some numbers around. That's all we've done so far. But is there anything you guys want to chat about? Okay, I'll flip the next 2 rows with you guys, and then have you guys flip. Maybe I'll flip the middle row with you guys, and have you do the remaining top and bottom one. Could I get somebody that hasn't helped out yet today? Possibly. What's the flip of 1 over 2? I heard it. 2 over 1 or just 2? What's the flip of root 3 over 2? You just flip it. 2 over root 3. And what's the flip of 1 over 3? It's just root 3, the cotangent of 30 degrees, 1 over root 3. So I'd like you guys to do the flips for 45 degrees and 60 degrees. The cosecant of those angles, the secant of those angles, and the cotangent of those angles. We're just flipping numbers. That's all it is, guys. Flip, flip, flip. Yes. Okay. We're going to plow ahead, though. You'll have some catching up to when you get back. All right, here I come. The flip of 1 over root 2 is just root 2 over 1, root 2. The flip of 1 over root 2 is just root 2. The flip of 1 is 1. And on the bottom, the flip of root 3 over 2, 2 over root 3. Flip of 1 over 2 is 2. And the flip of root 3 is 1 divided by root 3, like that. Look at all those exact ratios we've done. I also get asked, when are these exact ratios ever going to be useful? And the answer is post-high school math. This is just where they're introduced in the curriculum. You're too busy in grade 12 functions and calculus doing other things. This is where we introduce this stuff. All right, look at all those exact ratios we have in a nice summary table that you guys can study from later on. Life is good. Second page done. We also learned how to determine exact values for trig ratios that have a related angle that's 30, 45, or 60. Anything you guys want to chat about? Kendall's squinting. Everything good? I can zoom in if you need. Oh, okay. Oh, you won a cookie contest. Congratulations. Your mom must be very proud. All right. Let's do just a few more exercises. Here we go, everybody. Again, we're just getting some practice doing some flips. This would have been an exercise, this exact example. I'm pretty sure it's in the grade 10 textbook you guys used last week. You would have been given some dinky triangle with whole numbers for sides, and your teacher would be, tell me the sine of angle A, and the cosine of angle A, and the tan of angle A. And we're going to do the same thing for B, but then what we're going to do in the grade 11 course is just flip all those ratios around. So if we're talking about A, now I'm going to write this temporarily, but if we're talking about A, 3 is the opposite, 4 is the adjacent. So we're time traveling back to grade 10 when you still played I don't know. I was gonna make a joke about a Roblox game. What's Bed Wars? Anyone still play Bed Wars? Yeah. Okay. You're back in grade 10. You're still playing Bed Wars, and then after that, you'll play Dress to Impress. But you're just learning about SOHCAHTOA, opposite, adjacent, hypotenuse. The sine of angle A is the opposite over the hypotenuse. It's 3/5. The cosine of angle A is 4/5. And the tan of angle A is opposite over adjacent. It's 3/4. That was grade 10U at the very start of the SOHCAHTOA unit. Grade 11U today just has to find the reciprocal ratios, but they're just flips. Can you guys flip those three fractions? You now have your three reciprocal ratios. Everybody can do this. I believe in you guys. 5/3, 5/4, and 4/3. That's all there is to it. It's just the reciprocals. It's the flip. Now, can you guys do the same thing for B? So people watching at home, and you guys here, I have the luxury of a different colored pen. So for when we're talking about angle B, the adjacent and opposite just switch around. So that's visible here. I'm using different colors. But you guys can use, I'm not your dad. You can use different colored pens. You can not include that on your note, whatever you'd like. But really quick, for angle B, can you guys do the 6 ratios? This would be a really good copy and paste for, like, say, your unit test. This question would be.
Is that a hint?
That's a very strong hint, yes. Well, I mean, most of your unit tests are just copy and paste from copy, paste, change a number. All right, let's do sine of B. This time the opposite is 4. So we have 4/5. For cosine B, this time the adjacent is 3/5. And since the opposite and adjacent change, the tan of B is 4/3. And then we flip them. 5/4, 5/3, and 3/4. We did it. And again, what have we really done today except introduce 3 definitions and then just flipped a bunch of numbers and just did math stuff you've already done in grade 10 or with Miss Scobie? I believe in you guys. We can all do it. Okay, let's do some questions that will just get you more used to these. And then also this last one will definitely help you with your assignment. So I am thinking of an angle in the first quadrant. So when you guys see first quadrant, you guys should be thinking, okay, it's acute. It's between 0 and 90. That just means this question is just calculator work. I'm thinking of an angle that has a cosecant ratio of 8. Now, if this was last unit, and you guys got to a point in a question where you had sine A equals 0.3456, you guys would just take your calculators and do sine -1 and get the angle. But your calculators don't have a cosecant button, so we just can't do cosecant -1 of 8. So what do? Well, we take the flip. We turn it into something involving sine. This means if cosecant of some angle A is 8, the sine of A would just be the flip, 1/8. That was manageable. Cosecant and sine are reciprocals. You just flip. And now this is something grade 10 you could have done. Now it's just calculator work. Now it's just, what's the inverse sine of 1/8 or 0.125 if you're converting to decimals? It's just calculator work. Shift sine. But yeah, we got to convert it to sine, cos, or tan first. Our calculators don't have those. If yours does, I'd love to see it. That'd be amazing. That seems small to me. I got 7 degrees. Okay, it's fine then. Let's just go to the nearest degree. 7 degrees. I'll do B with you, and then you guys will try C. Oh, we don't have a secant button. What do? we rewrite this in terms of cosine. If the secant of an angle is 7 over 4, the cosine will be 4 over 7. And now we can find an angle. You just do cos inverse of 4 over 7. Whatever that is. Hey, you guys are doing great today. 55 degrees. All right, I'm going to resist the urge to do C for you. I will wait. I will bask in the awkward silence. Just wait for you guys to do it. Oh, what happened to our screen?
It does that when you move a little. It comes back usually. A little
Okay,
while
just
after.
don't no touchy, hands off. Okay, came back. All right. When you guys all become math teachers, a really hard skill is actually just like being okay with doing nothing while people try stuff. As now I'm filling the empty silence with just useless words. Like you got to be okay with just letting people try stuff. But I think I've let you try enough. All right, cotangent. Don't have a cotangent button, but we just write it in terms of tan. The tan of angle C is 16 over 5, which is 3.2, I believe. But we just can keep things in brackets here, or in terms of fractions. Tan inverse of 16 over 5. This isn't so bad. 73 degrees if you round it to the nearest degree. 73. I see some knots. All right. We can do it. There's only one more kind of thing I'd like you guys to be able to do with the reciprocal ratios. Find an angle. All right. Now this question should look familiar. I think you have at least 2 of these on your green assignment, and then maybe another 2 where you're asked to find 4 angles using coterminal angles. We're going to find 2 angles between 0 and 360 that have a cosecant of -2. And my advice to you guys is always draw it out first. Think about this, guys. Using the cast rule, where are the 2 angles going to be using the cast rule? So cosecant, is that related to sine, cosine, or tan? And then use the cast rule. Which 2 quadrants will I be looking for here? Give you guys a second to think. And maybe even jot down a little hint here. So we're looking for angles where the cosecant of our angle theta is equal to -2. The one that pairs with cosecant is the sine ratio. This means we're looking for angles that have a sine ratio of -1 over 2. And just by doing that, this is now a question Miss Goby has done with you guys. Find 2 angles with a sine ratio of -1 over 2. And you guys should be used to this by now. That means we're looking for 2 angles in these 2 quadrants. Why these 2? Because those are the quadrants where sine is negative. So we draw things first, and then we use our calculators. Whatever our calculator gives us, that unlocks what we're going to do next. What do we get? What did you guys get when you did inverse sine of -1 over 2? I will do it as well. I think it's -30. -30, right? -30 degrees. The sine of -30 degrees is -1/2, which means the cosecant of -30 degrees is -2. That angle works, but list a technicality. We're looking for angles between 0 and 360, so we got a bit of work yet. But that means we can actually still move the needle on your diagram. Can you guys just add 30 degrees? That's what we just found, is it not? -30 is rotating clockwise. That's the angle we found there. We've actually found that reference angle. Theta r, that acute angle, is 30 degrees. And you can add it to both sides. And you guys have done literally tens of these by now. Now, what angle between 180 and 270 makes an angle 30 with the x-axis, and the same thing between 270 and 360. So for our first angle, we're 30 more than 180 degrees, 210 degrees. And then for our second one, we're 30 less than 360. 360 degrees minus 30 is 330 degrees. We've got our two. They have the right sign. And if you're on the green assignment and you're asked for 4, well, let me just ask you guys, what if I change the question to 4 angles? Can one of you guys tell me what I would do to get 2 more? 4 angles between, say, 0 and 720? Using yesterday's stuff? Jesse? You can add 360 to each of these, right? Perfect. Okay. So that went really well, guys. You took that like champs. I really mean it. Good job. You'll be probably pleased to know that there's only one more topic this unit that's exclusive to you guys. Most of next week, I have a plan where you and the 3M